Alright, in this lesson we're going to look at sex-linked traits. Sex-linked traits. These are traits that are found on the chromosomes in the 23rd pair, on those sex chromosomes or the sex-determining chromosomes. In the karyotyping lesson we looked at pictures of chromosomes and how you can count chromosomes and determine if there are chromosomal mutations. And we talked about the fact that if you are male in the 23rd pair, you have an X chromosome and a Y chromosome, right? And that really looks like, here's a big old X chromosome right here, here's a Y chromosome. And the Y chromosome just has its centromere kind of attached at the top. If you are female, you have two X chromosomes, right? So you have an X and another X chromosome. Okay, and they're the same size, shape, and everything else. There are two types of sex-linked traits then, okay? The ones that are Y-linked are only found on the Y chromosome. Now the Y chromosome has a totally different set of traits and characteristics than the X chromosome. So what that means is only males are going to get it because only males have Y chromosomes, and they're going to get passed from father to sons. You don't really need to worry about the Y-linked traits. So this is not on, the EOC. Okay? The one that you need to worry about is this one right here, the X-linked traits. Okay? X-linked traits are the ones that are going to be found on the X chromosomes. And what that means is that the male is only going to get one copy because he only has one X chromosome. The female is going to get two copies. So if you're female, what that means for you is you've got two shots at the non-recessive allele, right? If you're male, you only get one shot at it, which means if there's a recessive disorder or something like that found on the X chromosome, the male has a more likely chance of being impacted by it because he doesn't have a second X chromosome that could possibly cover it up. Females have that second X chromosome. Alright, so we've got what is a sex-linked trait. There's lots of traits that are out there that are sex-linked. Colorblindness, hemophilia, certain forms of muscular dystrophy, those are all sex-linked traits. Let's look at hemophilia. Okay, hemophilia is a blood disease. Oops. And what happens in hemophilia is that your blood doesn't clot. Okay, so if you accidentally cut yourself and you have hemophilia, you could bleed and bleed and bleed and bleed. Your blood doesn't stop coming. You don't scab over like normal. Even a simple bruise can be very, very dangerous for somebody with this disorder. Hemophilia is recessive, so we're going to call it little h. Non-hemophilia is the dominant trait, so we're going to call it big H. Now, we've got our alleles for this, right? But this is not a straightforward kind of Punnett square, and the reason for that is because you need to make sure that you're labeling the X chromosomes. If you don't do this way, what happens typically is students will forget that the male only gets one copy, and they'll try to figure out what the male's genotype is with two alleles. The male is only going to get one copy. So let's do a scenario where you have a carrier female Okay, so she's a carrier, and her husband is a man with no hemophilia. Okay, so we've got a man with no hemophilia there. Alright, so our carrier female, we know that means she is heterozygous, right? Here's how we write that. She's got an X with a big H, right? She's got an X with a little h. Okay? Now notice we're putting down that she has 2 X chromosomes, and then we're labeling the trait on those X chromosomes. The man with no hemophilia has an X with a big H. Okay, because he doesn't have hemophilia, so he's got the dominant trait. The other chromosome that he has is a Y chromosome. Okay, and we don't label the Y because this is not found on the Y. So when we put this onto a Punnett square, and your Punnett square will typically be larger here, just because you've got a lot more stuff to put in the square. When we put this on the square, I'm going to make it nice and big here. Okay, here's Mom on the side, and we'll put Dad up here. Okay, when we put this on the square, notice you have a daughter with 2 X chromosomes here, right? And both of hers are dominant, so she does not have hemophilia. You have a daughter who is a carrier for hemophilia. You have one son who does not have hemophilia. And then we have this one son who has hemophilia. Okay? So when you look at this, there's some questions on your note sheet as you're going through this. So on this Punnett square, you're being asked how many of the kids have hemophilia. The only one with hemophilia is this one right down here. Okay, now where did the hemophilia trait come from? Where did this X with the little h come from? Well, what you'll notice is Dad, who's up here, right? Dad gave everybody here a Y chromosome, right? So this X with the little h came from Mom, right? So it's typically the case where these sex-linked traits will be passed from mothers to children. Okay, and usually that means that the male has a greater chance because he only gets 1 copy. All right. Can there be males that carry hemophilia? Well, to be a carrier, you have to be heterozygous. Is it possible for a man to be heterozygous for one of these traits? No. Look, he's got 1 chromosome that can carry it. The other chromosome cannot. Okay, so when you only have 1 chromosome, you either have it or you don't, and there's no such thing as being a carrier. Only females can be carriers. Okay? So males are going to be the most likely impacted because they only get 1 copy. Alright, so other traits. I mentioned colorblindness, right? Let's look at colorblindness. Red-green colorblindness. Whoops, sorry. Let me switch over here. Colorblind. Okay, red-green colorblindness is recessive, okay, and I'm going to use the letter N for this because C's are bad letters, okay. Color vision is the dominant trait here, so we'll use a big N for that. Oftentimes students will ask me the question, well, is it possible for a woman to get a sex-linked trait? And the answer is yes, it is possible for a woman to get a sex-linked trait. Typically when that happens, it has to do with a trait that's not life-threatening. So things like muscular dystrophy and hemophilia, you don't typically see people, males with that living long enough to have kids, because you would need a dad, and I'll show you in a minute, you'd need a dad that has the trait to have a female get it as well, because she'd need a copy from her mom and a copy from her dad. So those are examples, but something like colorblindness and also baldness. Male pattern baldness is also sex-linked, and the reason why it's called male pattern baldness is because males are more likely affected. But it is possible for women to get one of those traits. So let's just do a quick look at this. Let's say we've got a carrier female. Again, and we've got a colorblind male. Oops, colorblind male. Okay, so our carrier female is X with a big N, X with a little n, right? Our colorblind male is X with a little n and a Y, right? Okay, and again, colorblindness, not life-threatening, right? So, having colorblindness does not mean that you're going to die before you reach reproductive age. And that's the key for passing these on to little girls. All right, so here's Mom. We'll put her on the side again. Here's Dad up here, right? Okay. Here's a little girl with that is a carrier, right? Here's a little boy that is not colorblind. Here's a little girl who is colorblind. See how she's got 2 copies of the recessive allele? She also has a brother here who is also colorblind. Okay, so it is possible for females to get these. It's not impossible. If this were something more life-threatening, though, like muscular dystrophy, it would be less likely that you would see a daddy that could live long enough to reproduce with a carrier female to have this scenario emerge. Okay, it's not impossible, but it's less likely.